Hello, welcome back to Chapter 8, Section 2, Multiplying and Dividing Rational Expressions. Finally, we get to multiplying rational expressions. What do you think the next video is going to be? Alright, so if you remember, I'll put it up here in the corner, if you remember multiplying fractions, okay, the easiest one to think of, the second easiest one. Let's say that you're going to make a pan of brownies. I want brownies all of a sudden. Okay? And let's say that, let's say your grandpa made the brownies. All right? So your grandpa says, you and your brother and sister, 3 of you, can have half of this, and I'm going to give the other half to grandma. All right. So first we cut the pan of brownies in half, and then since we don't want brothers and sisters to argue, we're going to then cut it into 1/3. So what fraction of the overall do you have? So if all these are equal, then you get 1 out of the 6. Okay. So here's the math behind what we just did. So you have 1/2, and you get 1/3 of that. In order to make this equal to 1/6, notice that 1 times 1 equals 1 and 3 times 2 equals 6. So when I multiply, and there you go, there's 5th grade math. When you multiply two fractions, you multiply the numerators, you multiply the denominators, and then you reduce it or simplify it. Well, that last step, the reducing or the simplifying, that's what we've been working on so far in this section. So that's where the factoring and that cancel or reduce part comes in. Okay, so basically what I'm going to do is, like for this problem, I've got 2 times x to the 4th times y to the 5th times 15 times x to the 2nd power. I'm going to factor all that, and I'm going to write it as one numerator. So 2 is prime, x to the 4th is 1, 2, 3, 4, x to the 4th, y to the 5th, 1, 2, 3, 4, 5. Now, by the way, I don't recommend you doing it this way. I'm doing this because I'm explaining what's happening. You might be able to figure out some sort of a shortcut, okay? 15 factor is 3 times 5, and x to the 2nd power is another x times x. This is expanded form. 2x to the 4th, y to the 5th, times 15x squared. This is all divided by 3x squared, which is 3 times x, times 8. 2 times 2 times 2, x to the 3rd, x times x, y to the 2nd, y times y. Woo! Okay. I'm looking for factors in the top that are the same as factors in the bottom, numerator and denominator, because those are going to simplify to the number 1. So 2 over 2, or 2 divided by 2 equals 1. X over x equals 1. Here's another x over x. 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 It doesn't matter which one you pick, they're all good. Let's look at the y's. Here's a y, here's a y. Okay, what else do I got? Here's a 3, here's a 3. What else do I got in the bottom? I got 2 times 2 left. Do I have any 2's in the top? No, I do not. So now it's time to remultiply and simplify. So I've got, what's left? I got y times y times y times 5 times x. That's going to be 5x y to the 3rd power. What's left in the denominator? 2 times 2, which equals 4. Now, is there a shortcut for doing this? Probably. If I add 4 plus 2, I get 6. 1, 2, 3, 4, 5, 6. And if I add 2 plus 3, I get 5. 1, 2, 3, 4, 5. And 6 subtract 5 equals 1. So that's why I get that extra, that 1x left. Same thing with the y's. I get 5y, y to the 5th power in the top, so I got 1, 2, 3, 4, 5. And in the bottom I got y times y. Where are they? They're over here. And 5 subtract 2 gives me my 3 that I have left over. And then of course you can figure out all the constants. But again, why did I do it this way? If I just wanted to do this, if I was like on an SAT test and I wanted to do this, I don't think I'd write it all out like that, okay? That's not the point. But the point is, I'm going to factor everything, and if I have a factor in the numerator that's the same as in the denominator, then those simplify because of the power of the wonderful number 1. Okay. Same thing with this problem, except now I got 3 fractions. I got x to the 7th, 1, 2, 3, 4, 5, 6, 7. 20 is 2 times 10, which is 2 times 5. 15 is 3 times 5. 2x is 2 times x. And x to the 4th is x times x times x times x. So right off the bat, I know those 5s are going to go away. And it looks like I can also reduce some 2s. Didn't matter which one I picked, it's both good. If I'd picked that one, somebody said, why didn't you pick that one? They're both good. And then let's go through the x's. I've got 1, 2, 3, 4. Looks like 5 of the x's are going to be able to simplify. What's left in the top? 2 times x times x times x, which is 2x cubed. And in the denominator, just 3. And again, you can probably do it easier if you did 1 plus 7 is 8, 1 plus 4 is 5, and 8 subtract 5 gives me my 3. And of course the 2 over 15 times 2 is 30. 2 over 30 is going to give me 2/3. But that's not the point, because these are not important problems. What do you mean? These are the important problems. This is why we're doing this. And by factoring and canceling and remultiplying, now I can do these problems. Okay, so let's look at this. X plus 2, that cannot be factored, so I'm just write x plus 2. X plus 4, these are being multiplied, so I can do this. All right, that's cool, that's cool. In the denominator, I have 3 times x plus 12, so I have a common factor of 3, which leaves x plus 4. And x squared subtract 4, that's the world famous difference of 2 squares, which gives me x plus 2 times x subtract 2. I guess I should extend that a little bit more. Now I have binomial factors and that 3 greatest common factor for everything. Both of these x plus 2, x plus 4, those don't factor any further, but the denominators did. So what's going to reduce cancel? The x plus 4 and the x plus 4, those are. And I'm going to draw a line through it. I don't want to, but this one looks complicated if I don't. So I'm going to draw a line through those. And I have the x plus 2 and x plus 2 here. So looks like both of the factors in numerator, I want to say denominator, numerator got simplified. Well, what got left, remember you're always multiplying by 1. So I got 1 over 3 times x minus 2. Now this is okay. You can also write 1 over 3x subtract 6. That's actually better. But for our purposes, it's okay if you leave it like this. You'll see that on the homework and the other stuff. Hey, by the way, there's something that I forgot to mention in the previous problems. It says, assume that all the expressions are defined. You know what that means? I don't have to do the x does not equal. Okay? In this case, x does not equal 2 or negative 4 or positive 2. But they're saying, hey, that was on the previous problems, you don't have to do it for this one, which I think is kind of weird, but we'll just go with it. All right, finally, we got this one. Oh my Lanta, this one looks really, really hard, but it is not. Look at each part. I have this numerator, this denominator, that denominator. I can factor all of these except for x plus 3, which cannot be factored. It's already simplified. So right here, 10x subtract 40. They have a common factor, a GCF of 10. So that's 10 times x subtract 4. That's being multiplied by x plus 3. In the denominator, x squared subtract 6x plus 8. What two numbers multiply to give 8 but add to give negative 6? That's going to be x subtract 4, which is nice because I see an x subtract 4 there, and x subtract 2. What about over here? They have a GCF of 5, and that leaves x plus 3. All right. Oh, and you know what? Yeah, I kind of messed up. I don't know if you caught it. I'm telling you about it now. I said factor, and I didn't factor everything completely. That actually should have been 2 times 5. So I'm going to hide this and write 2 times 5. I should go to primes. Because the 5s are going to reduce. The x subtract 4s are going to reduce. And the x subtract, plus 3s are going to reduce. So the 5s. So what's left in the top? Just the 2. What's left in the bottom? Only the x subtract 2. And no, the 2's do not cancel. So don't try to do it. That's because this is x subtract 2, not x times 2. You can only reduce when you're multiplying in the numerator and denominator. All right. And of course, I don't know why they didn't do this, but can't let x equal 4, 2, or negative 3. But they didn't ask me to do that. All right, we'll see you in the next video where we're going to finally divide.